Hello everyone and welcome to Van Vehicle Skyscraper 2020. My name is Jason Pritchard and I'm the editor of eVTOLinsights.com. I'm really happy to have been given the opportunity to be part of this virtual summit, which talks about the implementation of urban air mobility in Latin America. In this video, I'll be speaking to Andrew Carter, co-founder, president and CTO of Resilience. He was part of Van Vehicle's sixth think tank, which talked about innovations in insurance. So I'll be getting more of his insight about the company's work and his views on the opportunities in the region as well. So Andrew, really good to talk to you today.
Yeah, I appreciate you having me on. This is exciting stuff.
Excellent. No, really appreciate that as well, Andrew. So are you able to tell me, for those that are watching, a bit more about the work that Resilience has done or would be doing with Van Vehicles, and what impact you think you can have as you, as Van Vehicles begins to implement urban air mobility in Latin America?
Sure. So we're really focused on monitoring the health and integrity of these safety critical ecosystems. I don't think anyone would argue that urban air mobility is not one of those systems. And what we see is that as these systems grow and more pieces and parts come in, the complexity grows astronomically. Having siloed monitors for each individual thing doesn't really help you understand within the ecosystem, how do you react when something goes wrong? When something over here is not working correctly, how does it affect, something on the other side that's going on? And so what we're developing is software that kind of looks across all of these things and tries to understand, how are things working? Are they working well? If there's some off nominal or adverse condition, what's the impact to both the system that it's working on and the whole ecosystem in general? And then what can we do to mitigate that? How do we reduce the impact as much as possible? And so in that vein, at a high level, we're really excited about the work being done in Latin America. We think Van Vehicles is really simplifying the problem in such a way that it can gain faster traction. But even as you simplify and simplify and simplify, you still get to a point where it's still pretty complex. You look at things like just a vertiport is going to be a mini airport that's going to need to be highly automated and able to get these eVTOLs coming in and out fast enough to really make any kind of business case for them. So we're excited to look at, how do we connect a series of vertiports? How do we, grow from one to multiple? How does problems within one impact other vertiports? How do we tie in air traffic flow control into that equation? And so, yeah, we think Latin America is a great place to really try to tease out some of these details, understand some of the complexity, even at a simplified level, in order to continue to build on that complexity.
No, really impressive there, Andrew, as well. And I think all the work that Resilience is doing now is going to be so important going forward as the ecosystem, as you say, begins to expand, and we're starting to see more and more pieces join that jigsaw as well. I wanted to talk, if possible, about the resilience framework that you mentioned in your presentation that's on the Skyscraper section. I believe it's currently being deployed in New York and Ohio, but what advantages could it bring to Latin America, where in some instances the terrain is a little bit different to those two states?
So Framework is our fault recovery and isolation health monitoring framework. It's really the flagship product of Resilience. And we focus on a terminology that NASA calls in-time system-wide safety assurance, or ISSA. So we're looking at how do we monitor and assess and mitigate the various faults, failures, or adverse conditions that are going to occur in operations, right? They occur every day in manned operations, and they're largely handled by pilot and ATC. As you become more autonomous and more highly automated and take the pilots out of the loop, that feedback loop has to be built into the actual ecosystem. And that's where our software comes in. So we believe that we can really help push the ball forward from a safety perspective by trying to get some of the humans out of the loop and get the system and the software to be able to mitigate these conditions in time to make a difference to whatever event is actually occurring or unfolding within the airspace. We very strongly believe that if every time something goes wrong with a UAM mission and they have to declare an emergency or call ATC or shut everything down, it's not going anywhere, right? If that's happening on a regular basis, the public trust, I think Van Vehicles is talked a lot about, getting public behind this. If you're in a failed mode, a large percentage of the time, you don't have a high uptime, a high availability, a high safety rating, you're never going to get the public acceptance.
Completely agree, Andrew. And I think public acceptance is that one issue that van vehicles and many others in the industry is trying to tackle as well. And I think it's that issue that needs to be tackled sooner rather than later in order for this ecosystem to work, isn't it? And you really touched on a really good point as well, is safety. It also, as well as public acceptance, is such a critical factor for the kind of eVTOL aircraft that we fly in and around the cities as well. What do you think, in your opinion, Andrew, would be the first things we'd need to be doing in Latin America to get this implementation working?
So I think it's a tough question to answer, first, second, third. I think I look at it more of what are the gating functions? There's a whole lot of things that need to be done in parallel. But there's a lot of things that we're not going to be able to take the next step until they're done. I think one of those is certification of the aircraft. Nobody's going to jump in an aircraft to fly, across the city without some kind of certification. I think a lot of the certification agencies are struggling with how to deal with machine learning, non-determinism, artificial intelligence, all these things that aren't present in manned aviation. How do you get through a certification process with that? I think that's a big one. I think the traffic management element, we're not going to be using ATC for these largely as they scale. So how do you, so you're in a different paradigm than manned aviation today. That's, new solutions. So how do you manage the traffic? How do you, essentially take the ATC function and put it into a digital environment, a software controlled environment? I think the safety assurance, the part that we're bringing to the table, is going to be a big one. Okay, you have all these things and you proved, at some demo that they worked, but what's my assurance that those things work day in, day out through every conceivable thing that happened? How do you build the robustness and the resiliency in there to give people, again, that comfort level? We talked in our panel about the insurance aspect. How do you bring insurance in to say, okay, we're going to underwrite the safety of these things when they're not comfortable with the fact that if something goes wrong, something terrible could happen. So those are a lot of the, I see some of the gating functions for this. There's individual technology elements, like detect and avoid is one that, gets used a lot. But I think there's, at a high level, I think the aircraft certification, the traffic management, the safety assurance are probably the three that we're focused on.
No, I really appreciate that, Andrew. And I think that's really important. And that safety, that risk as well, is people will be flying in these eVTOL aircraft and want to know that it's got the same safety certifications as a commercial airliner, as any form of transport they're traveling as well. So I think that's another real important topic we need to sort of go forward with as well. You mentioned in your presentation on Skyscraper, for those watching, really, really interesting. So do check it out, as well as this interview as well. That you mentioned, and again in the conversation, that the industry hasn't got anything to detect off-nominal or adverse conditions. Now, with the varying weather in Latin America, obviously with Bogota and the high altitudes and Cartagena next to the sea, what issues does that then pose in a way for implementation of urban air mobility?
Yeah, so when I talk about these adverse or off-nominal conditions, we've really broken those down into a few different buckets, and we actually work with partners on all of the buckets. So we look at weather, right? That's obviously a big one. We look at security. When you start to look at this kind of digital world and all the attack surfaces from a cybersecurity perspective, there's a whole lot of concerns there. And then the area that we focus the most heavily on our software is really around the health and integrity of the ecosystem and the data. Things like sensors, automated, talk about a vertiport, a battery charging system, all the web-based software that's providing this digital infrastructure. And so when we focus on the weather, to your question a little bit, one of the things that we look at is how do you detect the weather? Right now, the low altitude wind information, which is extremely important to these operations, is largely not known. Further, in cities where you have all of the various effects of the winds from the buildings, from the heating of various things, has a huge impact, right? One of the weather companies we work with a lot, True Weather Solutions, uses the term the Venturi effect. I don't fully know what it means, but they always make a spinning symbol with their hands when they talk about it. So I assume it's not good for a UAS to fly into. And so what we look at is how can we distribute IoT weather sensors that aren't $100,000 a piece, right? How do we put cheaper sensors around a city to both monitor and model that weather? And then what our software is looking at doing is how do we make sure that those cheap weather sensors, which don't have extensive built-in tests, are working correctly, right? If one of them gets stuck, right, and is measuring zero wind when there's a gale force wind coming through, or one of them is just going nuts and putting in these huge measurements into the system, we don't want that to affect air traffic, right? So we need to both monitor and model the weather in these areas that we're going to be doing these high volume traffic in, and then have a very high assurance level that what we're getting from those weather systems is the actual weather and a good confidence of the future predictions.
No, that's really interesting as well, Andrew. And I guess the early days will be critical into how you get that data as well. And I'm glad you mentioned True Weather. We had a really, really good conversation with Don Birchroff, the CEO, and he was talking in quite a lot of detail about how important weather data is when monitoring these eVTOL aircraft. So that's really interesting as well. Do you think sort of that data collection is going to be so important in the first sort of years when it is the eVTOL aircraft is operation, isn't it? How would that then pose challenges sort of to try and get that data in the first instance? Because effectively we don't know how these vehicles are going to react in the weather when they're not yet being built yet, if you know what I mean.
Yeah, I think the data question or the data challenge goes much beyond that. We've had in the U.S. there's been a number of initiatives that have collected data. The problem is that data usable across initiatives? Are we collecting it in such a way that we can aggregate it, that we can glean insights off of it for the next thing or a different region, or is it only useful at a time and place and with the systems that it was collected for? So I think as an industry, identifying how we collect this data in such a way that it's useful for certification agencies, it's useful for air navigation service providers or civil aviation authorities, to really provide a comfort level that we can take that data and we can mine it and we can say, this is what we predict is going to happen based on all of the data that we have. I think that's hugely important for the industry. And yeah, I think that, going forward, being able to define and identify and store and then get that data out, I think is another issue, is that some groups have collected a ton of data and consider that their proprietary advantage, which very well, it's a viable business model, but it doesn't help move the industry forward, right? So I think there's a lot of standardization organizations, ASTM, GUTMA, JARAS, that are the whole the rising tide raises all boats mentality, that we need to collect data and get it out there and get it into the hands of industry and regulators.
Yeah, completely agree, Andrew, as well. And it kind of goes back on the whole collaboration, doesn't it? I know Brown Vehicles and these think tanks have been brilliant to really bring the industry stakeholders together and to have those conversations that when the implementation does start happening, we're already asking and answering those questions that we posed at the start as well. Are you able to tell us a bit more then, with the work that you've done in Ohio and New York, as we mentioned earlier in our conversations, what value do you think you could bring to the Latin America region then, as it is quite different, as we were saying, to the terrain that you're used to working to?
Sure. I think the terrain is probably not as important to what we're doing as the systems involved. And we anticipate very similar types of systems. It might not be the same vendors of every system, but we anticipate the same types of technology being involved, in Latin America as it is in New York and Ohio, in the U.S. and Europe and Asia. We need to be able to, talk to aircraft, right? We need some kind of comms. There's going to be some operations and controls type center, whether that's in a vertiport or it's a more regional based, similar to almost like an ATC type for low altitude aircraft. There's going to be likely some surveillance for manned and unmanned aircraft. There's going to be, probably V2V communications for smaller drones when you talk about the urban air mobility. You're probably not going to try to detect with radar every small drone in the sky. Huge problem with birds there. So I think there's very similar types of technology and capability. For instance, on the weather sensor side, the weather may be very different, but the same sensors and the same technology used to detect and predict the weather aren't going to change overly much. So I think our focus is more on the types of capabilities and services and features and capability that are needed to realize the vision in Latin America, and less so on the challenges with anything around the region itself. Because really what you're going to do is put this infrastructure and this capability in, and then you're going to use the data you get to adapt to that region.
No, good stuff there. Thanks for that, Andrew, as well. And am I able to touch upon the work that Resilience is doing with vertiports? I know that you're working around sort of the automation on that, and I saw some bits on the website. But are you able to talk to us a bit more about the work that you'll be doing when these vertiports are starting to be built, especially as they're going to be in what could be quite densely urbanized areas in Latin America?
Yeah, absolutely. And I think the work there is still fairly nascent. What we've seen is that most companies that we've talked to that are looking at essentially putting in vertiports are more in the real estate development industry. They're looking for where's the right place for a vertiport? What are the structural requirements for a vertiport? What we haven't seen very much of yet is what are the technology requirements for a vertiport? How do we get 100 flights an hour, to make up a number, in and out of this thing? How do we detect, have very good GPS, precision navigation accuracy? How do we have a very strong comm so we're always in contact with landing and taking off aircraft, which is the most critical flight segment? How do we charge batteries efficiently? How do we get people on and off? How do we move aircraft around to a loading and unloading versus a landing and takeoff area? I think there's a lot of things that are going to be automated within a vertiport. We anticipate vertiports having their own command and control center, looking at things like traffic management, flow control, all of the various pieces I just mentioned around the vertiport, being maintained and controlled from a single location. And so that's the area that we anticipate being involved in. We're talking to many companies that are, again, looking at the real estate side, and once they're ready to start looking at the technology side, I think we're ready to be part of that picture.
I completely agree, Andrew, as well. I think it's really important that while the real estate sides are on about building the physical vertiports, I think it's really important having a company like Resilience to, as you say, work with all the technology sides, because we're all working to the same goal, aren't we? It's all about that collaboration and that working together. Because what we don't want to have is with the ecosystem, little bits, components that are a bit further along and some that are a bit lagging behind. So, is there anything that you feel we could do as an industry to make sure we're all coming up to the same page at the right time when these aircrafts are operational?
I think that's a tough question. I think the standards organizations are doing a really good job at that. I think the problem in this industry that we've seen has largely been around funding. Almost everything has been self-funded. There's been very little, I'll say, public funding, to try to, consolidate those views around some national strategy for really any country. And so we see that, people that are spending their own money don't want to really share their solutions with everybody. Small startups may not necessarily be able to get involved in standards. Standards organizations it takes a lot of time, and it's all, unpaid work. So I think there's the standards bodies are probably the way to get everybody up to a level that's at least compatible. And then I think some of it's going to be driven by market needs. Where are people making money now that they can mature the technology that can then be expanded on, adapted, or evolved into kind of the growing needs. So I think that's probably a much bigger challenge than maybe an outsider might realize to get right for quite a few different reasons.
No, thanks for that, Andrew. I completely agree on the points as well. Is it until it's happened and until the aircraft are all up in the air, it's sort of difficult to sort of work to get to where we're going to be as well. I just wanted to go back, if that's okay, to resilience framework software. So as you rightly say, uptime and fault detection is so important, especially if these aircraft are going to be autonomous or on predicted flight paths. Are you able to give us a bit of an insight into what would happen if, for example, the framework detects an issue? Again, public acceptance is very important, and they want to know that the aircraft they're traveling on is safe. Are you able to tell us a bit more about how that would work then if a fault is detected?
Sure. So detection is kind of step one in the process. Once we've detected something is wrong, the next step is, what do we do about it? And that can take many different forms. The first part of that is assessing the impact. Does this fault affect just my little system? Does it affect multiple systems? Does it affect an airspace region? Right? Who is going to be impacted by this? What is the extent of the impact? Is this for a fault on a UAM vehicle? What's my flight time remaining? Is this something where I'm going down now? Do I have 3 minutes of flight time, 5 minutes of flight time? And then being able to inform a contingency management process. So we anticipate that process is going to be probably have a human in the loop, similar to ATC, but likely with more automated tools where they can see what's going on, be given a choice of, here's some automated solutions to take, or possibly procedural solutions that you should be taking, and be able to inject some kind of mitigation into the system. So for instance, in this case, if you have an urban air mobility vehicle that thought it had 20 minutes of flight time left and a battery issue is detected, and now we think we have 10 minutes of flight time left, we might say, okay, what are the software might say, what are the nearest vertiports, what's open, right? Do all of the kind of background calculations, and then give a user, these 3 vertiports have an opening or could take this aircraft right now. Which one do you want to use? In the future, at some point, that could be fully autonomous, fully automated. We believe that there's probably going to be at least some kind of human on the loop for probably the near term until a lot of the technology matures, a lot of the certification processes are worked out.
That's incredible, Andrew, to think that the framework system can detect those sort of critical faults as well. I mean, how much of an impact will that have, do you think, in the first instance when these aircrafts are flying, in terms of helping to sort of mitigate, as you say, any faults in the future? Because essentially it could help to manage any faults that happen in the start so that it can help in the future, if that makes sense. So,
yeah, I mean, I think that we think that there's a large role to play in this. We're trying to really build out the framework for this in-time system-wide safety assurance concept to be built into the ecosystem, with the ability to bring in third-party modules, because we don't look at anything, proprietary data, right? We treat everything as a black box, and we're doing most of our work on the data available in the ecosystem. But many of the components are going to have, highly specialized built-in health and integrity monitoring that we want them to be able to plug into the framework, so that once they do their thing for their piece based on their proprietary data, they can then use that to communicate out, so that the rest of the ecosystem, again, can look at the impacts, can look at what mitigations should possibly be taken to those things. So we think by providing kind of this layer of in-time safety assurance, that we can, make a scalable, evolvable ecosystem that's going to continue with that level of safety as we grow and learn. We have more data available. We can make smarter decisions.
Brilliant. No, really, that's great, Andrew. And wishing you all the very best going forward with that as well.
Thank you.
Continues forward. I just wanted to go back onto as I said at the start, you were involved in the 6th think tank with Found Vehicles about the innovations in insurance. But are you able to talk a bit more about how much you've benefited then with the work that you've done with Found Vehicles, and just as a think tank as a whole, in bringing these stakeholders together to have conversations, not just about innovation, about the implementation, about vertiports as well? How important do you think the think tanks have been in helping to identify where we need to start in terms of the implementation in Latin America?
I think they've been great, and primarily because of the audience. I think a lot of the audience that we see at a lot of trade shows and events is a lot of the technology providers. Most of those people know everything I just told you, right? We're not educating them in many way, shape, or form. But when you start to get policymakers involved, you start to get the insurance companies involved, You start to get people that aren't just day to day in these industries, but are going to benefit from them, or want to see them, or want to understand how this stuff is coming together. Again, how does public acceptance work? What are the safety implications? I think that's where the real strength is, and what's been done with the think tanks. And I think it's been very, very successful. We've been excited to have conversations with people that we necessarily wouldn't normally be approaching on some of these subjects. I think, as Skyscraper goes forward and gets that larger audience, that again is not just the technologists, I think that's where the strength lies.
Completely agree, Andrew. Yeah, I think the think tanks have been brilliant to try and bring and expand that ecosystem. So we're all having those conversations as well. It's brilliant to see sort of just how much opportunity can be brought to Latin America's region. But from your point of view, Andrew, with all the experience you've got at Resilience, what opportunities does it give those living in Latin America, do you think, with all the autonomy and all the sort of the systems as we've just talked about as well? What opportunities do you think that can bring to the region?
So, I'll first off saying I've never actually been to Latin America. So this is most of this is talking to Felipe and the Our Own Vehicles team, but understanding the congestion, understanding the ability that you some places you go to somewhere like Texas, and when there's more people, a highway gets wider, right? There's a lot of space. You're not constrained. But then on my own experience, you go to somewhere like Boston, and there's no place for the highway to get wider. My understanding is that Latin America is largely constrained much more, like an old East Coast city, where you just don't have the space. So congestion problems, pollution, all the things that urban air mobility is trying to solve, kind of globally. I think it's a prime example of an area where those things exist, that has the need and the environment that can thrive in.
I think it's, sorry to show that straight on to you. I myself, I've not been to Latin America myself, but from the conversations we've had with Felipe and the think tanks, it's really helped educate my sort of understanding of it all as well. So brilliant. Thanks for that, Andrew. Some really, really good stuff. I really appreciate you talking to me all through with the bits with everything at Resilience. But is there anything finally you wanted to add about the work that you're doing at the moment, what you might be doing in the future to help this implementation in Latin America?
I think the only thing that I would potentially look forward to is one thing. We've talked a lot about safety, but didn't necessarily talk a lot about risk. So one of the areas that we're looking at is, how do you measure the risk to an operation where something may have not necessarily gone wrong or failed or had some adverse condition, but how do you develop the algorithms to look forward and say, I think something might go wrong, or something is going wrong over here, and I think there's a risk to things over here, even though I haven't detected necessarily that they're affected yet. So I think that's an area that we're working with NASA on right now that we think is going to be highly important around comm, nav, surveillance, and weather. How do you measure the risk? How do you predict the risk? And then how do you communicate that risk to the operations that are ongoing? How do you reroute from a traffic management perspective? How do you reroute traffic around high risk areas? How does onboard equipage of the craft itself affect whether they can fly through a risky area? For instance, if you're flying by LTE comms, but you have a backup SATCOM system and there's an LTE outage in an area, maybe you're fine. If you don't have that backup SATCOM system, maybe you shouldn't be flying there. So I think, outside of just the safety assurance, looking at how risk is calculated and affects operations is kind of the next step for resilience.
And I think sort of just a final point onto that as well, Andrew, is it must be trying to manage that risk for different cities as well, because there might be some cities that are big, sprawling urban environments might be completely different to those that are a bit smaller as well. So it's all about sort of not thinking that every city is exactly the same, isn't it? They're different.
Yeah, that's a good point. And what we've actually developed, we call it our configured rules engine. Our system is highly configurable because we don't believe any of the thresholds that are going to be the same anywhere we go. We believe that you're going to have to understand what the risks are, what the rules are in that area, and that's going to determine what the output of the software is. None of that can be hard-coded. Most of that's not going to come from a standards organization. We're going to have to do data collection, do modeling and simulation, do actual flight tests, and all of that is going to, as we learn, get pumped into the software And then again, as you learn there, then you can start automating it.
And I guess all that data collection and that flight testing, and you can only benefit the industry as well, because you're effectively laying the foundations for more testing and things like that as well.
That's the idea. Absolutely.
Excellent. No, I really appreciate your time, Andrew. I think it's been really interesting talking about the risk and the safety management as well. And I appreciate your end bit about the risk as well, because I think the more we can talk about that and people can get an idea of kind of the points and the questions that you're asking as well, that it's really good to help understand that as well. So yeah, really good talking to you. I wish you all the very best with everything at Resilience, and I'd like to continue the conversation going forward. Thank you also for everyone for watching the video as well. Don't forget, there's a whole amount of content available to watch on the Skyscraper section of the Van Vehicles website, which includes Andrew's presentation on Resilience, their framework and everything that they're doing as well. So please check that out, as well as this one as well. The website is www.vanvehicles.com/Skyscraper 2020. So Andrew, for now, thank you very much, and we'll look forward to continuing the conversations.
Thank you. Have a good one.